A sampling distribution is a probability distribution of a statistic obtained through a large number of samples drawn from a specific population. In repeated sampling, they tell us what values of the statistic can occur and how often each value occurs. Sampling distribution have four types. First, distribution of the sample mean. Second is distribution of the difference between two means. Third, distribution of the sample proportion. And fourth, distribution of the difference between two proportions. For the first type, distribution of the sample mean divided by 2, which is normally and non-normally distributed population. For sampling from a normally distributed, the shape is normal irrespective of sample size, and the mean of the sampling distribution of x bar equal to mean of the population. This is the formula of the standard deviation, and this is the formula of z value. For example, the foreman of a bottling plant has observed that the amount of soda in each 32 ml bottle is actually a normally distributed random variable with a mean of 32.2 ml and a standard deviation of 0.3 ml. The question is, if a customer buys one bottle, what is the probability that the bottle will contain more than 32 ml? We want to find px32, where x is normally distributed. Given mean and standard deviation, we just insert into the formula and we'll get the answer. There is about a 75% chance that a single bottle of soda contains more than 32 oz. Next question is, if a customer buys a carton of 4 bottles, what is the probability that the mean amount of the 4 bottles will be greater than 32 ml? This is the solution. We want to find px32, where x is normally distributed with mean 32.2 and standard deviation 0.3. The things we know is x is normally distributed, therefore so will x bar. Mean equals to mean x bar equals to 32.2 ml, and this is the standard deviation. We just insert into the formula and we'll get the answer. Next, we insert the value into the formula and we'll get 0.9082. There is about a 91% chance that the mean of the 4 bottles will exceed 32 ml. Next is sampling from a non-normally distributed population with mean and central limit theorem. If random samples of n observations are drawn from a non-normal population with finite mean and standard deviation, then when n is sufficiently large, usually n more or equals to 30, the sampling distribution of the sample mean is approximately normally distributed. Sampling from a non-normally distributed population with mean and standard deviation. The mean, the sampling distribution of x bar equals to mean of the population, the standard deviation formula, and then the value of z. For example, the weight of UTM students are approximately normally distributed with a mean of 60.2 kg and a standard deviation of 3.3 kg. Random sample of size 40 is drawn from this population. Determine the mean and the standard deviation of the sampling distribution of x. The probability that the average weight is below 58.5 kg. Solution. Just insert the formula to get the standard deviation, and then this is the mean, and then we insert into the formula to get the z value. Next, we look at distribution of the difference between two means. The sampling distribution of the difference between means can be thought of as the distribution that would result if we repeated the following 3 steps. First, sample N1 scores from a population 1 and N2 scores from population 2. Compute the means of the two samples, mean 1 and mean 2. Compute the difference between means, mean 1 minus mean 2. The distribution of the differences between means is the sampling distribution of the difference between means. This is the formula, the mean, the standard deviation, and the z value. For the third type, we will look at distribution of the sample proportion. First, population proportion P, ratio number of elements in a population with specific characteristic to the total number of elements in the population N. Sample proportion, ratio number of elements in a population with specific characteristics to the total number of elements in a sample N. This is a formula for population proportion and sample proportion. Capital N is the total number of elements in the population. Small n is total number of elements in the sample. Capital X is number of elements in the population that possess a specific characteristic. Small x is number of elements in the sample that possess a specific characteristic. Mean and standard deviation of sample proportion P. Mean of P is equal to the population proportion. mu P equals to P. Standard deviation, P is population proportion, Q is 1 minus P, and N is the sample size, assuming N over N less or equal to 0.05. Shape of the sampling distribution of the sample proportion, central limit theorem. The sampling distribution of P is approximately normal for a sufficiently large sample size. In the case of proportion, the sample size is considered large if NP larger than 10 and NQ larger than 10. Thus, the Z value of P, this is the formula. For example, a soda filling machine is supposed to fill cans of soda with 12 fluid ml. The soda bottler claims that only 5% of the soda cans are underfilled. A quality control technician randomly samples 200 cans of soda. What is the probability that more than 10% of the cans are underfilled? This is the solution. N equals to 200. P is underfilled can 0.05, Q is 0.95, and P is 10 and Q is 190. We just insert into the formula and we'll get the Z, and then we'll get the answer. Lastly, we look at distribution of the difference between two proportions. In both populations, there are events with the first proportion for the first population and the second proportion for the second population. And this is the formula. The sampling distribution of difference between two sample proportions, the mean and the standard deviation.
In this lesson, we will learn about two types of estimates: the point estimate and the interval estimate. The point estimate is a single number calculated from sample data to estimate the parameter. Okay, I will show you an example of how to find a point estimation of a population mean. Okay, first of all, we should take out the important values first. Okay, so here I have highlighted the standard deviation of all students' grade points average was 0.4. So the standard deviation, the symbol is 0.4. Okay. Now a sample of 900 graduates was randomly selected. So sample is N equals to 900. Okay. And then the mean GPA of the sample is 2.7. Okay, so now we will answer the first question. What is the point estimate of the population mean? Okay, so A. Basically, since the point estimation is a single value of the parameter, so we just take the mean answer. So the point estimate of U is, the population mean is 2.7. That's it. Now for the second question, what is the margin of error? So first, we have to find the standard deviation of the mean. So this is the usual formula to find the standard deviation of the population mean. So this one equals to, we take the value that we have taken out, 0.4 over the sample 900 equals to You got it? Okay, but this is not the margin of error yet. Okay, in order to obtain the margin of error, we have to times this value with plus minus 1.96. This is like the common error for point estimation. So the answer is 0.0261. Okay, now we have solved the problem. Now for the next type of estimate is the interval estimate. The interval estimate is a calculation of two numbers to create an interval within which the parameter is expected to lie. Usually, the interval estimation is stated in terms of level of confidence. The interval estimation can also be further divided into two. The first one, which is the interval estimation of a population mean, and also the interval estimation of a population proportion. Okay, now I will show you an example to find the interval estimation of a population mean. Okay, the average zinc concentration recovered from a sample of zinc measurements in 36 different locations is found to be 2.6 grams per milliliter. Find a 97% confidence interval for the mean zinc concentration in the river. Assume that the sample standard deviation is 0.3. Okay, since the sample itself is more than 30, which is more than 30, we will use this to find the population mean. Okay, first of all, we must take out the important values. So the average zinc concentration is 2.6 grams. So average mean is 2.6 grams. Okay, and then we need to find the value from the Z table. We have to know the coefficient first. So at 97% confidence level, the coefficient will be like this. So now we divide it by 2, will become so we will need to find this value in the Z table, and from the Z table we will obtain 2.17. Now we have the mean and the value from the Z table. Okay, next we will use this formula to find the error. So equals to S 0.3. Here the sample standard deviation. So 0.3 over the sample, which is 36, will become 0.05. Now we have the three important values to find the interval estimation of the population mean. So here so the answer will be, the point estimation would be in between 2.4915 to 2.7085. You can say that the real answer would be in between these two values. So now we can add the conclusion of the solution. We are 97% confident that the interval from 2.4915 grams to 2.7085 grams contain the mean of zinc concentration in the river. Okay, so this is a simple summary of how to find the interval estimation of a population mean. So when the sample size is more than 30 and the standard deviation is known, we will use this formula. And if we don't know, we will use this formula. Now, if the sample is less than 30 and the population approximation is not normal, we will increase the n to more than 30. So basically we will use this formula. And now if the population approximation is normal and the standard deviation is known, we will use this formula. And if the standard deviation is not known, we will use this formula. Be aware that we will this formula is different than this one, because this we will use a T distribution and not using the Z table. Now I will show you an example of how to find the interval estimation of a population mean when the number of sample is less than 30. Okay, firstly we will have to take out the important values first. So the x, the mean, is 230 calories. Okay, so, and since the confidence interval is 99% and we want to find this value, so basically at 99%, we will need to find the half of the coefficient and the number of degrees. The number of degrees is basically the number of samples minus 1. So it will become 0.0059. And from this value, we will refer to the T distribution table. And from the table itself, we will obtain 3.250. Now we will need to find the error. The error is, so the standard deviation given is 15. So 15. Number of samples 10. So now the answer is 4.7434. Okay, now we have the values needed. So we will solve it. So the answer will be in between 200 and 214.584 and 245.416. We now can conclude that we are 99% confident that the true mean caloric content of the energy bars lies in between 214.584 to 245.416 calories. Okay, for the next interval estimation is the interval estimation of a population proportion. As you can see, the population proportion is denoted by P and the sample proportion is denoted by P hat. This formula is used to find the population proportion, where P hat plus minus the value from the Z table times by SP hat. The SP hat is the root of p hat times q hat over the sample. Take note that the q hat is actually 1 minus p hat. Also, the point estimation of the population proportion is actually the sample proportion, which is x divided by the sample. The margin of error for this estimation is plus minus 1.96 times by SP hat. Now I will show you an example of how to find an interval estimation of a population proportion. As you can see the solution here, since p hat is basically the point estimation of the population proportion, so we just have to calculate using the formula given. So x is basically the non-conforming units, 114, divided by the sample units, and this is the answer, 0.1012. Next, B, find the margin of error. So the margin of error is basically the SP hat times by 1.96. So first we have to find the SP hat, which is equals to square root of p hat times q hat over n, the sample. So here, square root of 0.1012 times by 0.8988 divided by 1126, which gives us the answer 8.9878 times 10 power of negative 3. And we write it the MOE, which is the margin of error, like this. And the last question, construct a 97.3% confidence interval. First, we need to find the value from the Z table. So at 97.3%, as usual from the example before, we find the coefficient and then we will divide it by 2. We find it in this Z table, and here we obtain 2.20. So now we only need to put the values into the formula given for the population proportion. So p hat plus minus the Z and the SP hat, which is here, which gives us the answer of 0.0813, 0.121. Okay, so from the answer given, we can conclude that we are confident that the interval from 0.0813 to 0.121 contains the corresponding true proportion.
Determination of sample size. First, we need to know the maximum error, which is the symbol is E. The equation is Z alpha half multiplied by standard deviation of sample mean, or we can use Z alpha half multiplied by standard deviation divided by the root of sample size. There are three things that we need to know. First one is standard deviation, confidence level, and sample size. Standard deviation. The value of standard deviation cannot be controlled. It is based on the data collected. The second is confidence level. As the confidence level increase, the value of Z increase, the larger the width of the confidence interval. And the last one is sample size. As the sample size increase, the width of confidence interval decrease. As for the conclusion, the value of standard deviation, confidence level, and sample size can affect the width of confidence interval. Determining the sample size for estimation of mu. If sample mean used as an estimation of mu, we can be 1 minus by alpha multiplied by 100% confidence of error will not exceed the specific amount of E, which is maximum error. There are two formulas that we can use to determine the sample size. The first formula uses the standard deviation, and the second formula uses the sample of standard deviation. Okay, let's take a look at the example. The efficiency expert wished to determine the average time that it takes to drill 3 holes in a certain metal clamp. How large the sample will he need to be 95% confidence that his sample mean will be within 15 seconds of the true mean? Assume that it is known from previous studies that standard deviation is equal to 40 seconds. Okay, from the question, we can see that they have given the 95% of confidence, which is we can use to find the Z alpha half. And from the table, the 95% is equal to 1.96. And the second is they have given the maximum error, which is equal to 15. And the third is standard deviation, that is equal to 40. Okay, from here, we see that they have given the standard deviation. So, in order to find the sample size, we need to use the formula that can be used, standard deviation. And then, we just input all the information that I have given into the formula. And we got the 27.318. And then we round it into the 28. The final answer is 28. Determining the sample size for the estimation of proportion P. If sample P is used as an estimate of proportion, we can be 1 minus by alpha multiplied by 100% confidence error is less than specific amount of maximum error. When the sample size approximately, we can use this formula, which is sample size is equal to Z alpha half the power of 2 multiplied by P proportion and multiplied by Q, and all of them divided by the maximum error, that is power of 2. In order to determine the value of P, there are two conditions. Okay, the first condition is if crude estimate of P can be made without taking a sample, this value can determine the N. So, usually the P is equal to 0.5, and this method is called the most conservative estimate. For the second condition, take the preliminary sample of size, which is N is more and or equal to 30, and we can calculate the sample of proportion. Use this value as the estimator of proportion of sample. Okay, let's take a look at the example. Suppose that we want to estimate the true proportion of the defective in a very large shipment of adorable brick, and we want to be at least 95% confidence that the error is at most 0.04. How large the sample that we need if A. We have no idea what the true proportion might be, and B. We know that the true proportion does not exceed 0.12. Okay, in order to solve this example, first they have given the maximum error, which is 0.04, and they say at least 95% of confidence, which is we can use to find the Z alpha half. Okay, from the Z alpha half, the 95% is equal to negative 1.96. In order to solve the question of A, they said that we do not know the true value of proportion, that is B. So if we recall back the condition of value of P, they said that if we do not know the value of P, we can assume that P is equal to 0.5. Okay, from here, we got P is equal to 0.5. And now we can find the Q, which is 1 minus by P is equal to Q, which is 1 minus by 0.5, we got 0.5. And then we got all the information in order to put into the formula. And then the final answer we got is 600.25, and we round it into 601. And to solve the question of B, they said that the true proportion does not exceed 0.12. Okay, so here we can assume that actually the P of the proportion is 0.12. And if P is 0.12, we can find the Q, which is 1 minus by P 0.12, and we got Q is equal to 0.88. And then once again we got all the information, and we put all the information into the equation, and we got the final answer, which is 253.55, and we round it into 254.
Okay, for the chapter 7, which is the last chapter for statistics and probability, is hypothesis testing. Before we start with the example and the population mean or also population proportion, we will introduce to you guys what is actually the concept of hypothesis testing, null and alternative hypothesis, type 1 and type 2 errors, hypothesis test, and also p-value approach. So the first one is concept. Hypothesis testing is actually when you have a claim about a parameter or situation and you want to decide whether to reject or not to reject the claim based on sample statistics. So basically there are 4 steps of hypothesis testing. So the first one is state 2 hypothesis, which is H0 and also H1. And beside that, the second one is formulate an analysis plan. This is where we need to look for the alpha table, whether it is Z alpha table or T alpha table. The third one, carry out the plan and physically analyze the sample data. This is we are using the formula. And the last one is analyze result, whether we accept or reject our hypothesis. So the concept is done. The next one is null and alternative hypothesis. So null hypothesis is actually H0, H small 0. So null hypothesis is a statement about value of population parameter that is equal to some claim value. So this is test the null hypothesis directly, reject H null or fail not to reject H null, and also must contain equality. The next one is H1, H with small 1, alternative hypothesis, which the statement that the parameter has a value that somehow differs from null and must be true if H null is false. There are 2 possible decisions, reject or fail to reject the null hypothesis. Not we say fail to reject or not to reject rather than accept the null hypothesis. The terms in the distribution are the actual regions bounded by critical value. What is actually a critical value? Critical value is any value that separates the critical region. What is actually the critical region? This critical region is where we reject the null hypothesis from the value of the test statistic that do not lead to a rejection of the null hypothesis. As you can see here, there is a graph that you can refer to make your understanding increasing. The next one is one test. One test, not this one, the one that has 2 tests. Has 2 tests, which is right turn and also left turn. Right turn is happens if the H0 is equal and H1 is more than, which this is the point, which is this we need to point the right. So this is the graph. So when the H1 is larger than, so we need to point the right. So when we point the right, we need to reject the H9 here, or maybe we also fail to reject the H9 here. So values that differ significantly from H9. Yeah. So the next one is one test. Left in happen when H9 is equal and H1 is less than. When the H1 is less than, we need to point to the left in the graph. So this is the graph, as you can see, and either we reject H9 or fail to reject H9. Values that significantly here is from H9. So the last one is two-tailed test. Happens when the H9 is equal and the H1 is not equal. Not equal means less than or greater than. So it looks like this or maybe looks like this. So alpha is divided equally between the 2 tails of critical region. So this is the graph. Either reject H9 here or reject H9 here, and is type 1 and type 2 errors, which is this. Type 1 error is reject H null when it is true, and the type 2 error is fail to reject H null when it is false. So this is the table that you can refer when there is column in true in the population, return the null, reject the null. So when it is true, return the null correct, 1 minus alpha, reject the null, type 1 error. This is where the type 1 error happen. So if the true in the population is false, so return the null is type 2 error, and the reject the null is correct, 1 minus beta. 1 minus beta is type 2 error, so 1 minus something that you got from type 2 error. So the error analogy, consider a medical test where the hypotheses are H null, the patient has specific disease, H1, the patient doesn't have disease. Then type 1 error is equivalent to false negative. Example is saying the patient doesn't have disease when in fact he does. Type 2 error is equivalent to false positive, saying the patient doesn't have disease and it's right. So finish the third one.
So we move to the next hypothesis testing, which is 5 steps of the hypothesis test. So this is the 5 steps of hypothesis test. The first one is state the hypothesis. Then the second one is alpha. Then choose appropriate test statistic. After that, establish critical region based on alpha. And the last is make a decision. So done for the 5 steps of hypothesis test. We move to the next hypothesis test of a population mean. There is 2 hypothesis tests of population mean. So the first one is where mean is n is greater than or equal with 30. So the formula for the test statistic for the mean n greater than or equal to 30 is Z equal to mean minus by mu over standard deviation, or Z equal to mean minus mu over standard equation. So this is the equation for the first mean where n is greater than or equal with 30. So this is the example for the mean where n is greater or equal with 30. So as we can read here, the daily yield for chemical plant has averaged 880 tons for several years, and then blah 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 blah. Then for the first one, such as we can do here the first step, which is state the hypothesis. So first one, we state the hypothesis. So we can take from the questions before, which is this is where the hypothesis is 880 tons. So the null hypothesis is that is 880 tons. Then the alternative is not equal to 880 tons. So the second one, we pick the alpha where is state here at the last sentence, which is 0.05. Then we put it for the second step. We follow the second step. Then choose the appropriate test statistic, which is we take from the suitable formula. Then we put the value and so on, so we get the value. Then for the next steps is establish the critical region based on alpha. So after we get the alpha and so on, so we need to look at the table, so we get the value. And the last one, we make a decision. So after we conclude it, so we can conclude what is the questions one. So move to the second mean, which is n is less than 30. So we can see the test statistic formula here and here. So for the next example for the mean is, then here we can see Waterworks office insists that the average daily household water use in a certain country is at least 400 gallons on average, and then blah 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 until the last word. So we move to the answer, how to do the answer. So we must follow the steps also. Like the first one is state the hypothesis. So we look at the question and what value that inside the question we put it back. So the second one is alpha. It had given here. Then put it inside the formula. Then we get the value. Then establish the critical region. So we look at the table back. So we can see where the hypothesis for. Then we conclude that we accept or reject the alpha. So that is for the second mean. Then for we have done for the hypothesis test of population mean. So this is the next test population, which is hypothesis test of population proportion. So here is the test statistic for population proportion, which is larger sample. So this is the formula. Then we can see that Q, we can take it here, Q, where is Q is 1 minus P, and P bar is a sample proportion. Then for proportion, a sample is considered large if NP is greater than 5 and NQ is greater than 5. So this is the example. You can read here, a car manufacturer claimed that 5.2% of their new car will be returned back to them due to some technical problem. And then blah 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 blah. Then for the answers, which also we must follow the steps by steps. Which is the first one is state the hypothesis. So we must take it from the questions. So we find it. Then alpha we state here. And then choose appropriate test statistic. So we choose the great formula, but the formula here is only one. So we must use only this formula where the formula is actually flexible. We can change it according to the question. So the next one is establish critical region based on alpha. So we choose at the table. So then we conclude it. So we get the same as detail. So done for hypothesis test of population proportion. So the last one is p-value approach. So p-value approach, we see that p-value is probability of obtaining a test statistic more extreme than the observed sample value given H0 is true. Also called is observed level of significance and the smallest value of alpha for which H0 can be rejected. So this is the steps by steps. So the first one is state the null and alternative hypothesis. Then identify the significant level, which is alpha. Then compute the p-value based on compute value of test statistic. Then establish critical region based on alpha and make decision by comparing the p-value with alpha. So after that we draw the appropriate conclusion. So this is a little bit info, which if p-value is less than alpha, so the h0 will be rejected. But if the p-value is greater or equal to alpha, so the h-value do not be rejected. So this is the example. Question: tomatoes with normal plantation technique will have a mean diameter size of 8.2 centimeter. So then we can read it. So how to answer it is by following the step before. First one is that the null and alternative hypothesis, where we can take it from the question, then identify significant level, which is alpha, then compute the based on test statistic, choose the best test statistic, then we conclude, we can calculate. So then establish critical region. So after that we see at the table, so we can conclude that. And the last one is the last one is make a decision. So we make a conclusion from the calculation before. So done for p-value approach. So that's it from us. Thank you.